Here are the answers for the section 5-8 homework on page 180. Question 1. In the Saturn series of rockets, the length of the C5 rocket is 175% that of the C1 rocket. Together the lengths total 550. How long is each rocket? The Saturn rockets were the rockets used in the late 60s and 70s that sent astronauts to the moon. Remember, we have an old math book. That's why it's talking about these kind of rockets. Let's define variables to represent how long each rocket is. We have our C1 rocket, and the other one was a C5 rocket. We don't know how long the C1 rocket is. Let's choose X for that. It does tell us something about the C5 rocket in terms of the C1 rocket. The length of the C5 is 175% that of the C1. Let's make an expression that fits that. 175% in its decimal form is 1.75, and then times X. This expression is saying the length of the C5 rocket is 1.75 times the length of the C1 rocket. The second sentence says that together, that means add them together, it totals 550. So let's write an equation for that. X plus 1.75x equals 550. And now we'll solve this equation. 1x plus 1.75x is 2.75x, and that's equal to 550. Now divide by 2.75, and we get x equals 200. The letter X is the length of the C1 rocket. We found out that that's 200 feet long. To find the length of the other rocket, we substitute 200 for X and multiply by 1.75. That will turn out to be 350 feet. Number 3, a publishing company has 2 magazines. One is called News Report, and it is 35 cents. The other is called Fashion World. It costs 50 cents. Last month, the combined, think about what the word combined is going to mean later on, add together, the combined circulation of the two was 283,500 magazines. And the receipts, or the money earned from those magazines, was $104,550. How many copies of each were sold? Let's define variables for how many copies of each magazine there were. One magazine is called News Report. The other magazine is called Fashion World. Let's represent the number of copies of News Report sold with the letter N, and the number of copies of Fashion World sold with the letter F. Now let's go back to the sentences and try to create equations that use these variables. One thing we're told is the cost of each magazine. So News Report is 35 cents. So we can say 0.35 times N plus Fashion World costs 50 cents. So 0.50 times F equals the total amount of money from the magazines, $104,550. This equation has 2 variables. In order to solve for 2 variables, you have to have 2 equations. We need to have a system. The other thing we're told is the total number of magazines sold. So we can say N plus F equals 283,500. The first equation involves money. The cost of this magazine times the number sold, plus the price of this magazine times the number of them sold, equals the total money. The second equation involves the number of magazines sold. The number of News Report plus the number of Fashion World equals this amount of total magazines. So we have a system. We can solve with combination or substitution. I'm going to choose substitution. And I'm choosing to solve the second equation for the letter F. it will become F equals 283,500 subtract N. To get the letter F alone, we just need to minus the N to the other side of that equation. Now take this expression, which is what the F is equal to, and substitute it in place of the letter F in the other equation. We will have 0.35N plus 0.50, and then in parentheses, let's make our substitution. 283,500 minus N. Then we have equals and this number here. Let's solve this equation. First step, the distributive property. So we have our 0.35N still at the beginning, and now we're going to distribute the 0.50. 0.50 times this number here makes 141,750. And then 0.50 multiplied to the negative n makes negative 0.50n. And that's equal to the 104,550. Now let's combine like terms. The 0.35n minus the 0.50n is negative 0.15n. To save some room, I'm also going to subtract the 141,750 in the same step. So take the number on the right and subtract away this number here. This makes negative 37,200. Now to get n alone, we can divide by the negative 0.15. And the answer is 248,000. Okay, that's the answer for n. That's the number of news report magazines sold. Let's also find the answer for f. Take this answer for n and substitute it into this equation that we had made that had f in it. So we have f equals 283,500, take away the 248,000. That turns out to be 35,500. So the number of news report magazines sold is 248,000 magazines. The number of Fashion World magazines sold is 35,500. Number 9. Mr. Rhodes likes to take a walk at this speed, and he returns home over the same route by bus at this speed. If he wants to spend 2.5 hours on the entire trip, find the greatest distance that he can walk. One of the things we need to find out in the problem is, what is the distance that he can walk? But we know that distance is going to depend upon time, using the formula distance equals rate times time. So let's represent the time that he walks using a variable. So time that he walks, we might choose the letter t for. And then time that he rides the bus, we could represent with 2.5 minus t. If his total time is 2.5 hours, and he walks for t hours, we could subtract those two values to find the time that he's on the bus. Now that we have expressions involving time, let's try to get distance into our question. The distance that Mr. Rhodes walks is equal to his rate of speed times the time that he walks. That's 3 times t. The distance that he rides the bus is equal to the rate of speed 12 times the time that he's on the bus. What is the relationship between these two distances to each other? Those distances are equal to each other. So our equation is 3t equals 12 times 2.5 minus t. Let's solve this equation. First, the distributive property. 12 times 2.5 makes 30, and 12 times negative t is negative 12t. Now we can add 12t to both sides. We get 15t equals 30. Therefore, t equals 2. What was t representing? It was the time that he walks. We figured out that that was 2. What was the question asking us? What is the greatest distance he can walk? So if he walks for 2 hours, what's his distance? That's 3 times 2, which is 6 miles. So the answer to the question is 6 miles. The answer is not t equals 2. Number 15, a solution of silver nitrate dissolved in water is 12% silver nitrate. That means the other 88% would be water. How many ounces of silver nitrate compound must be added to 23 ounces of the solution to produce a 20% solution? So our unknown is, how many ounces of silver nitrate do we have to add? Let's represent that with a variable. If you've had chemistry class, then you know the symbol for silver nitrate is AgNO3. Let's represent that with a variable, such as x. Now let's read the sentence and try to create an equation. We're told we have 23 ounces of this original solution, which is 12% silver nitrate. That's telling us that 12% of the 23 ounces is silver nitrate. The rest of it is water. As a decimal, 12% is 0.12. Then there's a sentence that says we're going to add more compound to that solution. And we chose the letter x to represent that additional compound. So we'll write plus x. When we make that addition of silver nitrate to our original solution, we want to end up with a 20% solution. So we want 20% of the 23 plus x ounces to be silver nitrate. Here's our equation. Let's solve the equation. First, multiply these two together. This makes 2.76. On the right side, we need to do the distributive property. 0.20 times 23 is 4.6. And 0.20 times x is 0.20x. Next, let's subtract 0.20x from both sides. And at the same time we do that, let's subtract the 2.76 from both sides. We'll be left with 0.80x equals 1.84. Now we can divide by 0.80 to get x alone. And the result is 2.3. We were using the letter x to be the number of ounces of additional silver nitrate that we add to our liquid solution. So our answer is 2.3 ounces. Next, number 21. A vat, which is a big container, can be filled by the hot water faucet in 8 minutes. And it can be filled by the cold water faucet in 6 minutes. It can be emptied through a drain in 4 minutes. If the drain is accidentally left open at the same time that both faucets are turned on, then how long does it take to fill the vat? Our unknown is the time to fill the vat. Let's choose the letter T to represent that. There's a formula that fits this situation. It's work equals rate times time, where the work that we're talking about is the job of filling up the vat. Notice how this is very similar to the distance equals rate times time formula. Let's figure out the rate for the hot water faucet. We'll do that down here. What we have to work with is that the hot water faucet can completely fill a vat in 8 minutes. We can interpret that to mean that the hot water faucet can do 1/8 of the job per minute. Let's translate what we're told about the cold water faucet in terms of its rate. We'll do that right here. So the rate that the cold water faucet could fill up the vat. If it takes 6 minutes to fill the vat, then it can complete 1/6 of the job per minute. What I'm doing is I'm interpreting these times in terms of rates. Another thing involved in the problem is that the vat is draining out the bottom in 4 minutes. We can interpret that as a rate. So the rate that it drains can be written as 1/4 of the job per minute. Remember, all along, the word job that I'm referring to is the job of filling up or emptying the vat. Now let's go back to this formula that we had written about work. In place of W, let's substitute 1, meaning one complete job, or filling one vat. That will be equal to the rate that the hot water fills times the time that it's running, plus the rate of the cold water faucet times the time that that faucet's running, and then minus the rate that it drains times the time that it's draining. I'm using subtraction because it's losing water when these two faucets are adding water. Here's our equation. Because there are fractions in the equation, let's take advantage of a recent algebra topic and multiply everything in the equation by the lowest common denominator. The LCD of an 8, a 6, and a 4 is the number 24. Let's times everything by 24. So we're going to times this by 24, times that by 24, this by 24, and times this by 24. The reason we're doing that is for some reducing to happen. 8 into 24 3 times, 6 into 24 4 times, 4 into 24 6 times. Our new equation is 24 equals 3t plus 4t minus 6t. Now let's combine like terms. We have 24 equals t. What was t representing? It was the time to fill the vat, measured in minutes. So our answer is t equals 24 minutes. Next, number 27. A ski lift brings a skier to the top in 15 minutes. In 4.5 hours, an instructor makes 3 runs with his class, and then 2 more runs by himself at a faster speed. If alone he takes only 1/4 the time used in skiing down with the class, how long does it take him to ski down alone? So our unknown is, how long does it take him to ski by himself? Let's represent that with a variable. We could use t for that. Besides skiing down the mountain alone, the instructor also skis down with his class. Let's represent that with an expression. Time to ski with the class. There's a sentence that says when he skis by himself, it takes him 1/4 the time used when skiing with the class. So the time to ski with the class is 4 times longer than the time it takes him to ski by himself. Now that we have expressions for our times, let's go back to the sentences and try to create equations. The first thing that happens is the instructor and the class rides a ski lift up the hill. That takes 15 minutes. Then the instructor and the class ski down. We represented that time with the expression 4t. Then they go back up the hill and then ski down. Back up again, and then ski down. At this point, the class is tired. They go into the lodge for some cocoa and a rest. But the instructor rides back up the hill and skis down by himself. We chose the letter T to represent that time. He goes back up again and then skis down another time. Then he goes into the lodge to join the class for some cocoa. We're told that this totals 4.25 hours. But here's where we need to be careful. The 15s and the T's were measured in minutes. So we don't want to say 4.25 because then hours wouldn't be the same time unit as minutes on this side. Let's write the 4.25 hours in terms of minutes. So 4.25 hours times 60 minutes per hour. That's 255 minutes. Now let's solve the equation by doing some combining like terms. We have 4t, 4t, 4t and 2 more t's. That's 14t. Then we have 5 15s. 15 times 5 is 75 minutes. And that's equal to 255. Subtract 75 from both sides. We have 14t equals 180. Now divide by 14. And for t, we have approximately 12.85 when we round it. And this is being measured in minutes. Now, what was the letter T representing? It was the time to ski alone, and that's what it asks us. So we found out that it takes him about 12.85 minutes to ski down the hill one time. And the last story problem, number 29. At most, how much water may be evaporated from 300 pounds of a 2% salt solution to create a solution that is at most 3% salt? A 2% salt solution is a clear liquid that has salt dissolved in water. 2% of the solution is salt, the other 98% is water. If we evaporate some of the water away, we're going to increase the concentration of salt. We want to evaporate enough away that we end up with at most 3% salt. The question asks how much water should be evaporated. Let's choose a variable for that. So amount of water to evaporate. We might choose X to represent that. Now that we've chosen a variable to represent the amount of water to evaporate, let's try to model it using algebra. One thing I want you to notice, though, is our letter X is referencing water, not salt. So we have to be careful of that when we create our expression. We have 300 pounds of a 2% salt solution. That means that that is a 98% water solution. If our original solution is 98% water, then we can write 0.98 times 300 pounds. That's saying that 98% of the 300 pounds is water. When we evaporate some water, we write subtract the amount we evaporate. We want to create a solution that is at most 3% salt. But remember, we want to reinterpret this in terms of the water content, not the salt content. So if we want it to be at most 3% salt, we want to interpret that as being at least 90% water. The symbol for at least is greater than or equal to. 97% water can be written as 0.97 times the mass of our solution, which is 300 minus X pounds. Now let's solve this expression. 0.98 times 300 makes 294. On the right side, 0.97 times 300 makes 291. And 0.97 times negative x is negative 0.97x. Now we can add 0.97x to both sides. We have 294 minus 0.03x is greater than or equal to 291. Now subtract 294 from both sides. We have negative 0.03x is greater than or equal to negative 3. Now divide by the negative 0.03. Now x is alone. We divided by a negative, so the arrow switches. Negative 3 divided by negative 0.03 is 100. The letter X was representing the amount of water that we needed to evaporate to change the concentration of our salt solution. We found out that we want to evaporate not more than 100 pounds. For the review assignment, we're going back to page 177. We were solving equations that had fractions. The technique was to multiply everything by the LCD. So if this is 4, 5, and 2, the LCD is 20. Times by 20, times by 20, times by 20. The reason you do that is so the denominators cancel away. 4 into 20 5 times, 5 into 20 4 times, 2 into 20 10 times. So our new equation is 5t plus 4t equals 90. Combine like terms, and then divide by 9. Number 4, same thing. This denominator is 7, this denominator is 1, this denominator is 3. The lowest common denominator when you have 7, 1, and 3 is 21. So times by 21, times by 21, and times by 21. 7 into 21 cancels, leaving 3. 1 into 21 cancels, leaving 21. 3 into 21 cancels, leaving 7. So our new equation is 9r minus 84 equals 7r. Now subtract 7r from both sides. And at the same time we're doing that, we could add the 84. So we get 2r equals 84. Divide by 2, and we get r equals 42. Number 6, same kind of problem. Let's figure out the lowest common denominator when we have a 12 and a 9 and a 36. That is 36. So times this binomial by 36, times this binomial by 36, and times this by 36, and don't forget to times that by 36. Now let's do the reducing. 12 cancels out with 36, leaving a 3. 9 cancels out with 36, leaving a 4. 36 cancels 36. Let's write our new equation. 2c minus 15 times by 3 with the distributive property is 6c minus 45. Right here we have a minus sign. Make sure you think of that as being with the 4. Think of it as negative 4. So 3c times negative 4 is negative 12c. 2 times negative 4 is negative 8. Then we have plus 6c plus 53. And that's equal to 0. Now we can combine like terms. 6c plus 6c is 12c, but then take away 12c cancels away. There are no c's left over. Negative 45 minus 8 is negative 53. And then we're adding 53. That cancels away. Everything cancels away, just leaving 0. And the other side says 0. So this is a special case. There's no variable left, and we ended up with a true statement. This is when all real numbers work. So the answer for C is all real numbers. You can use any number you want for C, and the equation will be true. Page 174, we were simplifying complex fractions. You might put a 1 under this and a 1 under this so it has a top and bottom. That technique is to multiply everything by the LCD. So if this is 27 and 1 and 3 and 1, the LCD of everything is 27. So times by 27, times by 27, times by 27, times by 27. That cancels out, and that reduces to 9. So we have 5 minus, and then 5 times 27 is 135. Down in the bottom, we have 9 plus 27. 5 minus 135 is negative 130. In the bottom, 9 plus 27 is 36. Let's try to reduce that. Top and bottom are both even, so they for sure will reduce by 2. We're left with negative 65 over 18. This will not further reduce. Number 4, might put a 1 under here, might put a 1 under here, and put a 1 under here, just so everything has numerator and denominator. The LCD is going to be a squared. Times by a squared, times by a squared, times by a squared, and times by a squared. This crosses out. So we're left with 9 minus a squared on top, and in the bottom, a cubed minus 3a squared. Let's do some factoring to see if anything will reduce away on this. In the top, we can write it as 3 plus a times 3 minus a. In the bottom, we can factor out an a squared, leaving a minus 3. Now, does anything reduce? Nothing in the top matches the bottom, But we do have 3 minus a and a minus 3, which are inverses. They cancel out and leave negative 1. So our final answer is negative 3 plus a over a squared.